Welcome to Anu's classroom. So today we are back with another video, and in this video we will quickly summarize the entire whatever we have learned in block 1 before we are proceeding to block 2. All right. So the block 1 had 4 units. The first unit we were talking about collection of data. That is, we need data for any kind of business decisions to be arrived at, right? So for that, how we can collect data, what are the different types of data, all those things were discussed in this unit. So mainly we saw that data could either be primary data or secondary data depending upon whether we had collected it specifically for our study in question or it was collected for some other purpose, but we are using it for ourselves as well. Then, so if we collect it by ourselves for our study, then it is a primary data. But if we are sourcing the data from outside, which was collected for something else, then it is a secondary data. The sources of primary data could be surveys, interviews. It could be personal through mail, telephone, or video. We could be doing some experiments or we could be observing to collect our primary data. Now, once we have primary data, how do we edit it? First step is definitely to collect data. We need to have a questionnaire. Whether it be for experiment or observation, we need to have some basis or questions based on which we will be noting down our observations or responses, right? So the first thing is to create that questionnaire. Once we have the questionnaire, we take a small pilot survey. That is, we distribute that questionnaire to a very small set of people to know their opinions about the questionnaire, and based on that we can modify our questionnaire if required. And once we have our questionnaire finalized after the pre-testing, we use it to collect data by distributing it across our entire population. Once we have the data, then we have to clean up, and cleaning up is necessary to ensure that whatever data is collected is complete. That is, everybody has given responses to all the questions that is involved. If it is not there, we'll have to call them up or connect with them and say, hey, you have missed out on this question, you haven't filled the response yet, can I know what is your answer to this particular question? Like that, we should make sure that the data is complete as well as consistent and accurate and homogeneous. Accuracy is one thing which we cannot be sure because it depends a lot on the respondent, but again it is very important as well. If our data which is collected is not accurate, then there's no point in the study. So even though accuracy is something very difficult to ensure, we have to ensure it for the proper analysis and forecasting using that data. So next we saw what were the signs of a good questionnaire. Like, it should have a covering letter, we should keep the number of questions to the minimum, and the length of the questions should also be short, and we should make sure that they are not unambiguous and they don't need much calculation to answer. Now if they are we should try to avoid questions of sensitive or personal nature, and we should make sure that the questions are all logically arranged, and wherever required we should give footnotes and cross checks so that everybody knows what is expected out of them through that question. And so the next is coming to the secondary data. So secondary data could be from published or unpublished sources, but since secondary data is not something which is collected for our particular study, we'll have to use it with a pinch of salt. That is, we should make sure that whatever secondary data we are dealing with is suitable for our study, it is reliable and is adequate. Now, when an entire data is collected from an entire population, like the entire population of India, for example, you call it a census. But if it is collected from a small sample population, that is maybe a few people from each of the states of India and not the entire population of India, then we call it a sample. And most cases, census is not required a sample. A good sample is good enough to reach at conclusions, because just by the nature of a census, we can see that census takes a lot of time, effort and money to get it completed than a sample. And based on the context, we can classify data into quantitative and qualitative, and based on the content we can qualify it into sensitive, confidential, restricted, internal, private, public, like that. Okay, and most of the time we will be dealing with this context based classification, that is quantitative and qualitative data. The next unit we saw was regarding the presentation of data, that is how to classify data properly and how to chart that data. So classification of data, we saw that there is quantitative and qualitative, but then again quantitative, and then more than that we can also classify data on the basis of geography, like from which location, was it Asia Australia, US, Europe, like Africa, like that we can classify. That is geographical or chronological, like whether it was past historical data, maybe centuries old data, maybe the current one or something like that. Based on the chronology or the timeline, we can classify data. And then again, quantitative and qualitative. Quantitative could be continuous data, like perhaps the speed with which our vehicle is moving. That is a quantity, that is a continuous type of data distribution, because the data points are not discrete, that is, they are not standalone data values, they are continuous. Like for example, you don't go suddenly from 10 to 20. That rise from of your speed from 10 to 20 kilometers per hour, or maybe from 10 to 60 kilometers per hour, is a continuous process. It, you may go up, you may go down, and then you may again accelerate, right? It's not like first your speed was 10, then it became exact 20, then it became exact 30. That is not how we raise up. It is a very continuous and smooth increment or decrement of speed, right? So that is continuous data distribution. And then the other is discrete data distribution. That is, the values are what you can say, the values are discrete, that is, you can measure. For example, if you take discrete data, a coin toss, the coin can either fall on its head or its tails, or maybe it might stand upright, right? So the movement of data points from a head to a tail is not continuous. The coin is either going to fall on its head or it's going to fall on its tail. So such type of distributions are discrete distributions, you can say. That is, they only have fixed value points. There is no continuous flow or something like that in their data distribution. That is discrete. Now, coming to charting of data, we can chart data on the basis of bar diagrams, histograms, frequency polygons, or gives cumulative frequency curves, pictograms. All these way we can use to chart different types of data depending upon what kind of insight or what are the number of variables which we will be using to plot that data. And the reason why we are classifying data was also discussed, that is to condense data into chunks that will help us notice the salient features and compare values of different attributes, present it in a tabular form, and highlight the significant features of the data at a glance. And can also, once we classify data, comparing between data sets and within data sets also become very easy. Now, next we saw how we can prepare frequency distribution. That is, we have to place all the possible values or value ranges, if it is a continuous distribution, in ascending order or maybe in descending order, depending upon. But it should have an order. And then in the other column, we'll write down the number of times data fell in that value or value range. That is the frequency. So we have frequency distribution is nothing but a table having all the possible values on one column and its corresponding numbers of occurrence, that is frequency, in another column. For a continuous distribution, definitely the number of values or the value points will be divided into classes, that is maybe 10 to 20, 20 to 30, like that. So continuous distributions, the upper and lower limits, based on how it is set, it could be exclusive, inclusive, or open-ended. Exclusive means the upper limit will not be included in the class. Inclusive means the upper limit will also be included in the class. And open-ended is the very first class's lower limit will be like less than, and the very last class's upper limit will be like more than, like that. So like maybe less than 10 or more than 50, like that. If we write, it will be open-ended methods. And most of the time, because of its easiness to understand and properly distribute and all, we usually use the exclusive method of distribution. But in case you are using some kind of secondary data, and in that the distribution is using inclusive method, then we can easily change it to exclusive by using a correction factor. So how we use is that we calculate a correction factor and we add that correction factor to the upper limits and minus the correction factor from the lower limits, like that we can use. So how is this correction factor calculated? How we have to calculate the correction factor is, we take the lower limit of the second class and we minus it from the upper limit of the first class and divide it by 2. Like for example, you have two classes, 0 to 10 and from 11 to 20, like this. If you have two classes, then what we do is we take 11 minus 10, that is lower limit of second class minus upper limit of first class, and we divide it by 2. So you will get 0.5, right? What we will do is we'll add 0.5 to this upper limit of first class, and then we'll minus 0.5 from the lower limit of second class. So now my class will be 0 to 10.5 and 10.5 to 20. So this will be the way my class will be distributed. And now what happened is this became an exclusive distribution. Now, a few keywords that we have to always keep in mind are class. Class is a group of raw data. Class limits are the highest and lowest values which are included in a class. Class interval is the width, span or size of that class. That is difference between the upper and lower limits. How much is the width of that class? Midpoint is the middle value of the class. Like for example, if your class is 0 to 10, then your midpoint will be 5. Like that. And this is your 0 and 10 are your class limits, and 10 minus 0, that is 10, is your class width or class interval. Frequency is the number of observations that fall within this observation. Class frequency is the number of observations falling within the class limits. Cumulative frequency is the total of all the previous class frequencies and the frequency of the class against which it is written. Relative frequency is nothing but the percentage frequency of the class. So those were the important topics mentioned in the second unit. Now we come to the third unit. In the third unit, so first unit we saw how to collect data. Second unit we saw how to classify it, organize it and present it in a tabular form. Third unit we will be seeing how to summarize the data into a single point value. That is measure of central tendency. So what they are saying is that we can define measures of central tendency, or in other words we call it location. And what we do is we find a central value around which the data tend to cluster. So it is like we find one value, one representative value which can speak about the entire data set. Like for example, the average income or the per capita income. That value, it's a single value, but it represents the entire population. Now, we also saw what were the properties of a good measure of central tendency. That is, it should be very easy to understand. It should be simple to compute. It should be based on all observations. When you define a measure of central tendency, if it is a good to be called a good measure of central tendency, it should be based on all the observations. It should be uniquely defined and be capable of further algebraic treatment. And it should not be unduly affected by extreme values, or also called outliers. Then we also saw a few measures of central tendency of how to calculate them. Like the common ones were the arithmetic mean, the weighted mean, the median, how to calculate the median if n is odd or n is even, or if it is a continuous distribution. The mode, how to calculate mode. Mode is nothing but the maximum number of observations. Whichever observation occurs the most number of time, then that is the mode. Then we also saw in this unit, we also see that what is the relation between this mean, median and mode. That is, mode is 3 times median minus 2 times mean. 3 times median minus 2 times mean will give you the mode. So those were the things. Out of all these measures of central tendency, if we should always we will take this median measuring median formula, especially that for continuous distribution and we can try to find out the quartiles, percentiles and all. Like the other types of means that we find are the harmonic mean, geometric mean, and we saw the relationship between arithmetic mean, geometric mean and harmonic mean as well. Arithmetic mean into harmonic mean is geometric mean square. And we saw how to calculate quantiles. If you know the formula for median, you will be easily able to calculate the formula for quartiles, dectiles and percentiles. Then the fourth unit was related to measures of variation and skewness. Variations measure, or the measure of dispersion, describes the spread or the scattering of individual values around the central value. And the measure of skewness is how skewed the data is. And we also looked at the different measures of variation. We had absolute measures and relative measures. Like for example, absolute measure of range. Range is calculated by subtracting the highest value minus the lowest value. And to find the coefficient of range, we used highest minus lowest divided by highest plus lowest. Average deviation we find by summing up the the observation minus the mean, its sum divided by total number of observation gave the average deviation. If we were to find its coefficient of deviation, then it is average deviation divided by the mean. Quartile deviation is found by minusing the third quartile from the first quartile and dividing it by 2. And if we want to find out the coefficient of quartile deviation, we do that by subtracting the third coefficient from the first coefficient and dividing it by third coefficient plus the first quadrant. Standard deviation we find by summing up the individual observations minus their mu, the whole square, divided by total number of observation and its square root. This formula can be simplified as sum of frequency into the deviation square divided by n minus frequency into deviation divided by n whole square whole under root. Now, if we were to find its coefficient of variation, it is standard deviation divided by the mean, that is mu. Now, if you multiply it by 100, you get the percentage of variation. And as I said earlier, measures of variation and skewness. Skewness is the lack of symmetry in a distribution. We assume that a symmetric distribution follows the normal or binomial distribution curve. But actually, in reality, the distribution might be positively or negatively skewed. So that is also very important when we find out and can give insights to our data. We also learned about how to calculate skewness. We can use the Pearson's mode skewness, where skewness is equal to the mean minus the mean minus the mode divided by standard deviation. And for median skewness, we do 3 times of mean minus median divided by standard deviation. Now, when we use Pearson's mode skewness is when we have a very strong mode. If we have a weak mode or if we have multiple modes in our data set, then we go for the Pearson's median skewness. We also have Bowley's coefficient of skewness, which is used for open-ended distributions, and that is calculated through the use of quartiles. So it is third quartile plus first quartile minus 2 times the second quartile, the whole divided by third quartile minus first quartile. Another formula is third quartile plus the first quartile minus 2 times the median divided by third quartile minus first quartile. If whichever the measure we are using for finding out the skewness, if the skewness is 0, it means the curve is symmetrical. Greater than 0 skewness means it is positively skewed, and less than 0 means it is negatively skewed. So this was the summary of block 1. I hope this gave a quick refresher to what all we learned in the first block. Moving forward, we will be going through the second block from the next video onwards, which deals with everything that is to be there with regards to probability. The basic concepts of how to calculate probability, the different types of probabilistic distributions like discrete and continuous distributions, and the fourth unit we will be dealing with in block 2 is about decision trees. So I hope to see you all in the next video. Thank you for listening. Bye.